All right, everybody, welcome to the video here for lesson number 6 on polynomial identities. So for these identities, all we're trying to really do here is prove that both sides of the equation come out to be the same exact expression. If we can do that, we've done our job. Now, the better you're getting at multiplying quickly, the easier and faster these will go. So let's take a look at the first one. So it says x plus y squared. So one of the things that we learned in class was that when we see something that's a binomial and we are squaring it, the first term is going to be squared. The middle term is going to be 2 times the product of x and y. And the last term is going to be the y squared. Now, if you can't do that with mental math, it's totally fine. Just make your boxes and do your x, y, multiply it out that way. We're then going to subtract. Why that happened? We're going to subtract, and then it's going to be x squared minus 2xy plus y squared is all equal to 4xy. Negative means we're going to subtract. X squared minus x squared is nothing, so these are going to cancel. 2xy minus negative 2xy, well, that's a positive, so it's going to become positive 4xy. Y squared minus y squared, they're going to cancel also. So we're left with 4xy equals 4xy. So it's an identity because it's true, right? So we're going to say this is a true statement. Number 2, prove this is an identity. Now, we've been using this identity in our factoring method back in lessons 5. So let's prove that it actually works. So we could do some multiplication. So if we multiply this out, we get x cubed minus ax squared plus a squared x if we do all of our distributing. Then if we keep doing our distributing, we're going to get a, that's a minus, sorry. So we're going to get ax squared. We're going to get minus a squared x. We're going to get plus a cubed. If you look, everything in the middle here cancels. So we're left with x cubed plus a cubed equals x cubed plus a cubed. Number 3. Number 3 is talking about Mr. Hines. Sorry, excuse me. Exploring a statement, the sum of the product of 3 consecutive integers and the middle integer is the cube of the middle integer. He began filling out this table. So 3 consecutive integers means you're going to have 2 odds or 2 evens. So we're going to have some kind of situation here. So I did the first 2 for you. So it says 1, 2, and 3. So the sum of the so your product is multiply them all together, sum of the product in the middle term, and then square it, right, or cube it, so we can see if that works. So first thing we got to do here is multiply them out. So we have 2 times 3 times 4. Well, that's going to wind up being 24. The sum of the product and the middle term, well, that's going to be 24 plus 3, which is 27. The middle term is 3, so this is a yes. The next one, we get 120. If we multiply them all out, if we add 120 plus the middle term of 5, you get 125. Is 125 5 cubed? Yes. So after seeing that it works 3 or 4 times, we can probably guess that this is an identity. But let's try it. So to prove if this is an identity or not, we need to make some let statements. So it says the sum of the product of 3 consecutive integers and the middle integer is the cube of the middle integer. So we're going to let x equal the middle integer. All right, we'll use our little hint here. The reason why we're letting x is that's the piece that kind of means the most, so it'll be the least amount of work that way. So we'll make x plus 1 equal the next term to the middle. we'll make x minus 1 equal the previous term to the middle. So it says the sum. So we're going to add up the three integers. So the sum is going to become 3x, because I would have x plus x plus x is 3x, and the 1 and the negative 1 cancel. So that's the, oh no, never mind. Sorry, we have to find the product of these first. I jumped the gun. So the product of these is going to be x times x plus 1 times x minus 1. So the product of the three consecutive integers, I got to do that first, so let's not jump ahead. So the product is going to be x times x squared minus 1. Where did I get x squared minus 1 from? I remember from our factoring method, that's what factored to this. If not, make your boxes and do it out that way. Do your distributing. So the product of the three integers is x cubed minus x. So there's your product. And then it says to take the sum of the product and the middle number, and that should equal the middle number cubed. Notice the x's cancel, so this is an identity. It's true. All right, so in this previous question, when we did it with numbers, any consecutive integers we picked, this would work for, because it worked with when I used variables. That's what an identity does for us. Number 5, is this an identity? Well, knowing what we did in class, I could say that's x squared plus 8x plus 16. These are not the same, so this is not an identity. Justify your decision means you could just show math. Number 6, similar to one that we did in class, is this a right triangle? Well, the first thing we have to do is figure out which of the sides is the biggest. So if x is larger than y and y is larger than 0, if I was to just pick like two random numbers, like 5 and 6, right? So if I was to make x 6 and y 5, that would be 36 minus 25. 36 minus 25 is 11. This would be 2 times 30, so that would be 60. And this would be 25 plus 36, which would be 61. Making this the largest side. I just need to know what the largest side is. That's why I'm picking numbers there. So when I draw my right triangle, just like I did in class, I kind of already knew that x squared minus y squared was going to be a smaller side, because if I add something versus subtract it, addition is going to be bigger. I was just more concerned about which one was bigger out of these two. So then we can make 2xy the other smaller side and x squared plus y squared the largest side. It's important because if it's a right triangle, knowing the largest side tells me which term is C. So then I can say x squared minus y squared squared plus 2xy squared is equal to x squared plus y squared squared. Now again, if you're not that great with the multiplying, use your boxes. So I know I've been saying that the whole video here, so let's do one where we actually show all the boxes here. X squared negative y squared, x squared negative y squared. So then we have x to the fourth minus x squared y squared minus x squared y squared, and a positive y to the fourth. So this term is going to come out to be x to the fourth minus 2x squared y squared plus y squared plus 4x squared y squared. And if we use this first one as an example for this second one, I don't really need to make boxes for this. I know it's just going to become a plus instead of a minus 2. So it's going to become x to the fourth plus 2x squared y squared plus y to the fourth. Combine your like terms, you get x to the fourth plus 2x squared y squared plus y to the fourth, and that's all equal to, oh wait, that. So we've just proven our identity and we're all set. Hopefully that video helped. Hopefully Miss Brusler watched it because she's supposed to be checking these too. Good luck.